Hello, this is FlippedHarber for Precalculus. In this video we're going to cover section 3.4, synthetic division. Our objectives for this lesson are to use synthetic division to find the quotient of two polynomials, as well as using synthetic division to determine if a binomial is a factor of a polynomial. Our topics will include synthetic division and factors, and our outline for this video will talk about setting up synthetic division and talk about a very severe limitation on it. And then we'll look at using synthetic division to find the quotient and remainder, and using synthetic division to verify a factor. Now, synthetic division is a quick way to do polynomial long division. The problem is, the reason it's so quick is because it's so limited. We can only use synthetic division when the divisor, that is the polynomial that we're dividing by, is x minus some real number. Now, because it's so limited, you have to pay attention. You can only use it when you're dividing by x minus a number. So if it was 2x minus a number, we can't use synthetic division. If it was x squared minus a number, we can't use synthetic division. It's very, very limited, but because it's limited, it's very, very fast. So without synthetic division, if we were trying to set up this rational polynomial and we were trying to divide it, we would have to set up the long division like you see here on the bottom. I know that's a square root sign. I still can't find a division symbol in my equation editor, so just deal with it. Now, instead of doing it this way, let's go ahead and set up synthetic division for this. So what I need to remember is that synthetic division is good when I'm dividing by x minus a number. So what I have on the bottom is x plus 1. Well, just think of that as x minus a negative 1. Now I'm going to set this up a little bit different than you see it in the book. It's going to be set up more like you see it in Algebra 2. I start by putting a corner block in, and I put that number that is subtracting x. So since it's x plus 1, I put negative 1 in the corner block. Another way to think about it is you're always putting the opposite number that's with the x. Now then, next to that corner block, I line up all of my coefficients from the top polynomial. So 1x cubed plus 2x squared minus 3x plus 1. So I've got every single coefficient from the highest power on x, which is a 3 in our case here, all the way down to and including that constant on the end. If there's a missing term, if there isn't an x squared term, make sure you put a placeholder there. Put a 0 where that term would be. We'll see an example like that later. So now that I've got everything set up, here's the process. My first number, my first coefficient, I just bring straight down. I don't do anything to it, it just goes straight down. Now I take that number and I multiply by the number that's in the corner box. So negative 1 times 1, and that goes below the next number. Now I add. 2 plus a negative 1 is 1. Multiply again, add, multiply, and add. So we've completed the synthetic division. This last number, whatever that last number is, a lot of times it's going to be 0 for you. It's not this time, but that last number is our remainder. It's what we would have gotten as the remainder if we had gone through the long division process. All the numbers in front would have been the coefficients on the new polynomial. So that 1 at the very front becomes a coefficient on x squared. The next one is the coefficient on x, and the minus 4 is my new constant at the end of the polynomial. And we place the remainder on the top of the fraction with the x plus 1 on the bottom of the fraction. So the stuff in front is what the book refers to as the quotient. The number in the box is our remainder, and it goes over top of the binomial that we're dividing by. So when they ask you to use synthetic division to find the quotient and remainder, this is what they want you to find. Okay, so let's do an example where we're using synthetic division to find the quotient and the remainder. So we're taking x to the fourth plus x squared plus 2 and dividing by x minus 2. So I set up my corner block with 2 in there. Remember, it's x minus 2, so 2 is going in the corner block. Now, since I'm missing my x cubed and my x term, I put placeholders there. I put zeros there representing those terms in the polynomial. Now, as I go through the process, the 1 drops down. I multiply and add, multiply, add, multiply, add, so on and so forth, all the way until I get done with all my numbers. That last number is the remainder. So all of the numbers in front are coefficients on a new polynomial. Now, a lot of people always ask, how do I know what the first term is? Well, there's a couple different ways you can tell. The 10 is going to be your constant, so you can actually work forward. The 10 is your constant, the 5 goes on x, the 2 goes on an x squared, the 1 goes on an x cubed. But you can do this from the front because that first number always goes on an x that is 1 power lower than we started with. So since I started with x to the 4th, that 1 goes on an x cubed, and then I can work my way down. So here we see our quotient is x cubed plus 2x squared plus 5x plus 10, and our remainder is 22 over x minus 2. Okay, so let's talk about using synthetic division to verify a factor. That is, they're going to ask us, is this binomial, x plus or minus a number, a factor of a polynomial? And the way we do this is we just do synthetic division, but what we're interested in is that remainder number, the last number when we're all done. If that remainder is 0, then yes, the binomial is a factor. If the remainder is not 0, then the binomial is not a factor. So we go through the whole synthetic division process just to find out that last number. So here's a polynomial, f of x equals negative 4x cubed plus 5x squared plus 8, and we want to know, is x plus 3 a factor? Well, if we set up the synthetic division, put negative 3 in our corner block, line up our coefficients, we see that the remainder is not 0. So that means that it is not, I don't know why my numbers changed, but x plus 3 is not a factor because that last number was not 0. Okay, so let's take a look at an example where it will be a factor. New polynomial, we're checking to see if x minus 2 is a factor. So I line up my coefficients, including a 0 for the x cubed and a 0 for the x. Those are very important. If you forget them, you'll get it wrong. And I go through my whole process. Drop the 4 down, multiply and add all the way across, and we see that the remainder is 0. When the remainder is 0, then yes, that binomial is a factor of the polynomial. Okay, so that's it. Time for you to try some of these on your own. You're basically just doing synthetic division for 3 different reasons. 1, just for the pure fun of synthetic division. 1, to find the quotient and remainder. And finally, to see if a binomial is a factor of a polynomial. Alright, I'll see you in class and I'll see you online.